Hello. Hi. Do you hear me? Okay. So, hi, thank you for coming. My name is Alberto Mandler. I'm DTS founder and CEO, and we will talk about a little bit about new technology for fast forward the future of railways. So we will start with a small video. Okay, so if we look at the industry that we are working on, we have a big problem that we are unable to provide services that our customer would like to see. I want to address a couple of things that limit this. First of all is the single track capacity. So today, the main limiting factor of providing different services on the railway industry is the capacity of a single line. We are trying to multiplex, to put a lot of services on a single track, to provide direct trains together with suburban trains in a single track, and that's why we require hiring as much as possible the capacity of the line. But because of today's technologies and limitations of the technology, we are unable to put a lot of services there, and that's why far places or different places doesn't get good support, frequency of trains, and the time to get to destination is relatively high. The future of railway also requires a lot of infrastructure investment. The solutions today are very, very complex and very, very expensive. The fleets are relatively or very old, and to move or to port all those to new technologies will take a long time and a lot of money to invest. All the infrastructure, or most of the infrastructure also in Europe, is very, very old, and requiring new signaling system is a huge and costly expenses, but also it takes a lot of time to get there. So it's not that even if we have the right technology today, it will take a lot of years to get to something that will provide a good solution for all the different stations and situations. Existing rail, the existing rail capabilities are not a real alternative to roads. So, and we need to improve that, but it will get much worse. So we are facing an energy crisis today, and we believe that it will increase the demand for rail, while rail currently is unable to provide a good solution for that. Increased demand for e-commerce. So the e-commerce is growing exponential. More and more people are asking to deliver goods to their homes or send things. And we will see an increase of more than 20% on road congestion by 2030, caused by e-commerce. So the traffic jams will even be worse than today. And we see that there is a growth in car bigger than the growth in rail capabilities. Okay, so we see that most of the solutions of today are trying to drive to cars, and the cars will not be able to provide a good solution for transportation of tomorrow. We believe that train needs to be part of it, and the question is how do we do that? And the way to do that is a changing paradigm. Today, all the optimization is being done globally. So we are investing a lot in new signaling systems that will provide better capacity, but again, those will take a long time to reach there. We are able to bring only less than 10% of the kilometer passenger today to rails. This is a very low number. The most efficient and low emission terrestrial transportation means rail, and we are here in Innotrans that it's specialized to train. But if you look at all the conference, I was 3 weeks ago here in IFA on a mobility side conference, and we were the only train company providing technologies there. So if you look worldwide, most of the innovation that is done for transportation and the way that the world look at it is not by a railway solution, okay? And we need to face it. Most future investment are done on different transportation means. So the world has invested more than $200 billion in autonomous cars. And I think that everybody knows, and still in this conference for sure, that this is not the right solution for a sustainable future. Moving or standing with a Tesla in the traffic jam will not help transportation of the future, will not solve it. And the investment on railway innovation is very, very low compared to the other transportation means. So this is what we're saying. We need to change the paradigm. The private sector needs to invest much more on railway solutions. And the question is how to do that. So the private transportation, as I said, is not complying with the real requirement of transportation. Okay, standing on a jam will be there forever. And the only way to fix it is having a good and reliable backbone of trains. And the question again is how to get there. So we need a game changer, okay? A sustainable solution that reuses as much as possible. So taking new technologies that will not solve the problem if they are not capable of reusing as much as possible of the existing infrastructure and capabilities. And this is how we suggest to do it. So our technology is a coupling technology on the run. So we are able to physically couple two trains while running at a high speed. This is using so after the two trains are connected, they are running as a single connected train using the existing infrastructure, existing signaling system, okay? This is a simulation of this is the result of a simulation of a connection of two trains while running. One of the things that we are asked all the time is won't it be very scary for the passengers to connect two trains while running? So we prepared this simulation to show the feeling of the driver. The simulation starts at 100 meters distance between the two trains. And it is using real brake curves and a real controller system that is based, part of it was taken from aerospace control. So you can see here they are getting at less than 10 meters, and it doesn't feel bad. It is a very smooth connection. Of course, we have, if you want to discuss it, all the mechanism to connect the mechanical, to do the mechanical connection is not explained here. But after the two trains are connected, as I said, they are connected with a standard automatic coupler as if it was done in a station, okay? So after the two trains the two trains are connected, they behave as a single regular train running on a regular line. So there is no requirement to change the infrastructure at all or any signaling system across the entire network. We don't allow to connect anywhere, okay? So there are special local coupling zones where you can do this connection and disconnection of trains. This is a very important aspect of the capabilities because we don't require to change the network at all. So the only places that need to be treated are those places that are the coupling zone. There are some requirements for those coupling zones. These requirements are to be relatively straight and low slope, so it makes the solution or the physical connection easier. The coupling zones are segments of about 2 kilometers length. On those sections, a special treatment of the line needs to be done, and there are some, as I say, physical requirements. We did an analysis with the Delft University, and it shows that with less than 1% of the network being coupling zones, we're able to increase more than 40% of the capacity of the entire line. This is without doing any optimization to the schedule. It's important to know that also regulation-wise, it is easier because of the coupling zone. We need to show that it is safe to do it in a coupling zone, and after that, in the regulation, we expect to have only an exception to those coupling zones. So the regulation will not need to do an adjustment for our technology overall. It will have to be an exception, and it is similar to what is used in the aerospace industry, where they have different regulation for different places. Like in runway regulation, distance between planes is different than in the air. And we believe that it will ease the porting or the moving to this kind of technology. Of course, the coupling zone needs to be specially treated, okay? So there are special things that we need to put there, but are less than 1% of the network, so the cost will be relatively low. If you look also at reliability, because we connect two trains while running only on special places, then the requirements of the reliability of the system can be much lower. It's not that I'm trying to run two trains on a distance of 200 meters for the entire trip. It's only try to connect. It's a singularity of on the trajectory, and so the requirements of reliability there can be much more relaxed. So we will go to use cases because there are many, many applications in which you can use this technology to improve the existing capabilities of a rail. In this example, we have a straight line that is capable of running 160 kilometers per hour, and then we have a switch that requires reduction to 60 kilometers per hour, and then a speed up again to 160, and another switch of 60, and then another acceleration and a station in which we require the train to stop, and then another acceleration. In this case, we use relatively common train parameters. These are 300 meters trains. And this is a result of a simulation that tries to optimize the minimum headway between 4 consecutive trains. So if you look, this is distance and this is time. So the first train is here. The leading of the train is the blue line, and the trailer of the train is the orange one. If the distance between the two lines is bigger, it means that it takes more time to pass there, and so the velocity is lower. So you can actually see the switches. So this is one switch, this is the second switch, and this is the station. And now when the optimization tries to put the next train, it is drawing the next train, and you can see here the regulation restriction in terms of the braking capabilities. So I can't never cross with this line the previous one, because then I'm at lower than the absolute braking distance of the 2 consecutive trains. And the simulation tried to optimize to put the second train as as early as possible that doesn't break the regulation. In this case, the limiting factor, as you can see, is the station itself. Okay, and here we are in the limit of the regulation. This is moving block, by the way. We have simulations that shows also this on fixed blocks. And so the second train headway will be at 160 seconds after the first one. And this is the third train, which has a similar limitation out of the second train, and the fourth train with the same limitation. And we see that the fourth train is coming out at 478 seconds after the first train. This is the important thing. This is the limiting factor of the capacity. This is showing how much of a capacity we have. And so, sorry. So you can ask, okay, if I connect two trains in a station, then maybe I will gain also some of the capacity. And so we did a simulation in the same manner that tries to connect two trains on a station. In this case, the headway of the third train is lower because then you don't have the restriction on the second train to get out of the station. It will enter to the station while the second train is already there. It has to stop before the train, but that's part of it. And then we connect it. Usually it takes about 3 minutes to connect two trains in the station, so this is simulated here. And you can see that instead of gaining capacity, we are losing capacity. Of course, there are many places that it makes sense to do that, okay, because I want the train to continue and use only one slot later on. So later on I will gain capacity, but in this scenario, in which you have a straight line and you have stations in the way, you will lose capacity from connecting trains and not gain from it. So I want to show you an alternative. And the alternative is to connect dynamically two trains while running on this section of the line after the first switch. We like using switches because they reduce the velocity anyway, and it helps us to gain some more capacity. The velocity of the connection itself, it depends on the scenario. So there are places that it will make sense to do a connection at high speed, and there are places that it will make sense to connect two trains while running at low speed. Of course, the size of this restricted zone will vary accordingly, so it's something that we need to set up from upfront. It's part of the infrastructure analysis and build up, okay? So it's not that I will be able to design for something and do something else later, but it's depending on the infrastructure itself, the different optimization that you want to do there. And this is the result. So what you see here is that there is a zone in which we are not longer on the absolute braking distance requirement, so we are out of regulation in this zone. This is the special treated zone that we talked about, okay? And this is the connection of two trains while they are running. And you see that the fourth train is coming out on 331 seconds instead of the 400 and 500 that they were before. So we are increasing substantially the capacity and the capability of putting more trains there, even in this simple or very straightforward scenario, okay? We have scenarios in which the gain is much higher, but even in this simple scenario, and the reason for that is, and we like to look at this technology as an enabler, because today you have a bottleneck in your network, and the bottleneck is restricting your capacity, but there are many places in the network that are blocked because of this bottleneck, okay? That I can't put any service on them because later on they will need to come to this bottleneck, and so they are blocked, okay? So you can't put any service. So if you look at a schedule, there are many black places that you don't put support or any service, and it is because there is a bottleneck later on that prevents it. But using dynamic coupler, you will be able to provide some services there, even though today you can't. Again, so there are many use cases for this kind of simple technology. So The eye-level concept is very simple, connecting two trains while running. And the flexibility that it provides is enormous. And I will share with you a couple of scenarios just for the explanation's sake, to seek the explanation. In this scenario, we took Israel. Our company is from Israel. And today in Israel, per hour, there are 8 entrances to Tel Aviv. Tel Aviv is the big city. Okay? And this is a scenario from north to south. We have a single line there, and there are 8 entrances to Tel Aviv coming from this line. You see all the stations in Israel, quite a few stations in the way, although it's a small country, we have stations everywhere. So it's not a very efficient way to provide services because most of the time you are unable to really speed up between stations. But this is the way that it was built. And we tried to show an alternative to this solution, the solution that we have today, using dynamic coupling. So if you look at a direct train that's coming from Haifa, and we want a direct train, it's 100-kilometer distance from Tel Aviv, so you want a direct train, otherwise nobody will leave his car. But while this train is running, then it is blocking all the services on all the other places, all the other stations, that we can't provide any service there. And instead of that, what we suggest is each time that you put a direct train running from Haifa to the south, you can put another train that is starting from an intermediate station that also is direct train, okay? And while it is running on the run, it will pick up it, connect to it on the run, and continue together, entering to Tel Aviv as a single train. So keeping the same amount of entrance to Tel Aviv, provide a much better service. So this is a simulation. The first train that we put here is a suburban train, so it stops on all stations, okay? Blocks the line for a long time, but it provides services between stations. So most of the people are coming from Tel Aviv, from the north to Tel Aviv, entering to the 90-something% of the people are coming from the north. But you can see in the simulation that the trains that are direct are picking trains on the way without stopping and providing direct train solutions for many intermediate stations that today they don't have that capability at all. So they have only suburban stations, and they need to wait all the time, all the stations to stop and accelerate again, losing power. Of course, there is emission and also time. So if we compare the two options, you can see here for each station the frequency of the trains. So they have 3 hours from Haifa, 3 trains per hour out of the 8. The support from Haifa was only 3, from Atlit it was only 1, and things like that. And this is the average time. In this case, the average time is not that good metric, because if you have a direct train, you probably will prefer to use most of the time your direct train and not the suburban train. So from Haifa to Tel Aviv is less than 50 minutes for the direct train. So you're losing a lot if you're using the other trains. But it's a measurement, so we use it. It's a metric, so we use it. So take on account that for the real services, it will be much better, because we will not take on account the suburban train that is running there. But this is the frequency, and so we could increase the frequency on most of the places on more than 33%, some places even more. And we reduce the travel time significantly, okay? So making this a real alternative for car. If you have a direct train from any place in a dedicated track for you, to any big city, nobody will use the car anymore. This is a second example. In this example, we look at the future technology. So we have moving blocks, virtual coupling being worked today heavily. But still, as I told you, It will take a long time to port the entire network to the new technologies. You need to turn out all the signaling or sidetracks and put new things on the trains, and it will be very expensive and very time-consuming. So our suggestion is not that you don't need moving blocks anymore, because there are bottlenecks that you want to improve your capacity. So it's good that you want to put that, but do it only on the places that it makes sense. All the other network, leave it as it is. So if you have a fixed block network that it doesn't require more capacity, okay? And you have an old train that supports only fixed blocks. So when it is running on the line, and it enters the share line, which was ported to be ETCS or support ETCS level 3, now you can connect the trains while running and pass the entire share line, which is moving block, as a piggyback. And when it later on disconnect and go back to fixed blocks, and in this way you will gain all the capacity from the beginning when you are adopting moving blocks, but you don't require hybrid modes, and you don't require to do extensive changes to the entire line or the entire network to be able to put. And also, most important is that not all your locomotive needs to support moving block. Another example is, we call it antenna line, a suburban line that it's a straight line that has many stops. And it goes to a big city, so most of the passengers goes to the big city. In this case, you usually require a relatively large train because it will support a lot of people that are coming to the city, but most of the time the train will be almost empty, okay? The occupancy will be very low at the beginning and gain occupancy on the way to the city. Also, you need very expensive electrical infrastructure to get up to the last station to support this running train, which is heavy and consuming energy. So each time that it stops and accelerates, you are stopping and accelerate an empty train that it's very heavy. And in this simulation, we show also the energy consumption for this case. And it reached to the last station with almost 500 megawatts of energy consumption. And this is an alternative, so you can put a very small train at the beginning, even battery-backed, that can run up to 50 kilometers, so the first 50 kilometers can be without any electrical infrastructure requirement. It runs on battery. And the occupancy is much better, the efficiency is much better, the power consumption is much lower. And when it gets to a place where the critical mass requires the big train, then it connects to it while running, so it doesn't peak occupancy. Even charges on the way to the last station. And from now, it's the same regular train that you had before, but with 27% improvement in the power requirements. In this case, the weight of the small train was a third of the full train, so it's a third of the size of the train, and half of the distance was running by battery. And this is the case that we show, and you improve 27% the power consumption. Another example is for freight. Today, freight, the optimization is having a full-length train, maximum length train, because the freight has lower priority in the line, so they receive only small amount of slots. And the service that I are providing freight is very bad. It's because I have a few slots, and if I want to send to several locations, then I need each several slots only. I will be able to send the goods to this location. And this is very limiting. There was a work done in the Delft University also that shows that if we improve the main limitation of using freight in Europe, or freight trains in Europe, or moving freight by train in Europe is the frequency of the service. not the cost, but the frequency. Okay, so people would be ready to pay more if the frequency would be higher. Only 19% of the freight in Europe are being moved by train. Okay, this is not a sustainable solution. So using our dynamic coupling, what you can do is another aspect is that when you're sending a when you're sending a train from one source, the second source is blocked because the slot is for the first source, and the second source can't send anything. Otherwise, you need another slot. And using dynamic coupling, what you can do is put even two small trains. It's a quarter of a size, okay, not the maximum size. So the frequency will be much higher. You will be able to send to the same location a couple of times, while in the other alternatives you had to wait until you have your slot. But at the same moment, to the same two destinations, you can send from other places that share the line, okay? And in this video, we show how it is done. So I send two destination trains connected at the beginning. They use only one slot until the share line, and now in the share line they connect to each other. So using a single slot in the share line. And when they reach out of the end of the share line, they disconnect, and each of them goes to the desired destination. And they can again connect if you want. And so in this way, you can provide a many-to-many service for freight using a single slot on the entire network, okay? Another example, and it doesn't like me, the example, okay. Another example is for parcel trains. So today, parcels are hardly moved by rail. It's not that it's not used. So there are a couple of places in the world that they use trains for parcels. The problem is that the parcel train uses a slot. So it's either a parcel train or a passenger train or a freight train. So this is a big limitation and cost for the parcel, and one of the limiting factors why parcel trains are not being used. And so using dynamic coupling, what you could do is you could have a parcel train from the main hubs going to the suburban hubs. This train can be, again, battery-based. Each such train could replace between 10 and 15 parcel trucks. And we estimate that it can reduce more than 70% of the CO2 emission. Of course, reducing substantially also the traffic on the cities. And so entering the cities, instead of by truck, by train. This battery-based train can run, and using the existing schedule of passenger trains that are running anywhere in the network, they can connect to a train or trains in the way to their destination, connect and disconnect as required, and move across the network as a piggyback, not taking any occupancy of the line, not reducing the capacity because of that line. And then when they reach the destination, they can disconnect and go to a special side platform that is dedicated for freight. So not everywhere you will be able to do that. At the beginning, you could do it only on places that they do have more platforms. In this platform, you can charge or load and unload the parcels, and then this train can continue to the next destination or come back to the main hub, depending on the things that you want to do. We believe that this will be a real revolution because people are permuting anyway in rail. So if they are already in the station, they will prefer to pick and drop their things in the station instead of something waiting on their home, that usually you are not there when they arrive. And it will reduce the last mile requirements also for deliveries. And then later on, of course, if it makes sense, on places that make sense, they will build a new platform dedicated for it if it's something that really makes sense. So depending on whatever the needs are of the system. So we are DirectTrains. This is the team. We are an Israeli startup company working on this dynamic coupling idea, and we are looking for partners to help us develop this technology. We have a lot of experience from the air industry, aircraft industry, and we bring a lot of ideas from there. We were responsible for the tanker that you saw at the beginning, so we are familiar with this solution. This is a similar approach, and so in summary, we believe that the rail has to be the backbone of the future of the transportation, and today I don't think that it is being seen like that other than us. So only the ones in the industry believe that this is it, but the fact is that only 10% of the people move by train. It's not really part of a transportation of today, and it will hardly seen as a transportation of the future. We believe that dynamic coupling will enable the train to become much more flexible, giving much better services to different stations and shifting people to move to train. And we believe that this is the only sustainable, real sustainable solution. All the autonomous cars and things like that are not really a sustainable solution. And a real way to increase capacity with low cost and without changing the entire infrastructure. So if you have questions or you want to discuss potential collaboration, you are welcome to visit us at Hall 20, booth 275. And we have some time for questions if you are interested on anything. Any question? So it was that clear? Okay. So thank you very much, and enjoy your stay in Innotrans.